Example number 2. Is each fraction a perfect square? So there are two different ways that we can see if they're a perfect square. So if we put the fraction in our calculator, find the square root. Now, if this answer is terminating or repeating decimal, then it is a perfect square. Another way is if in lowest terms you have a perfect square, perf square over perf square. Alright, so let's launch into these fractions here. So A, 18 over 98. Now I notice that they're both ending in 8. That means they're both even, so at the very least 2 goes into both of them. So I want to get this into lowest terms because it is not. So this becomes 9 over 98 divided by 2 is 49. Here's the thing, it's very easy to see. If in lowest terms, yes, if you have a perfect square over a perfect square, well, 3 squared is 9, so that's a perfect square. 7 squared is 49. So you have a perfect square over a perfect square, so yes, perfect square. Yeah. Now we're going to call this method 1 because personally I find this one the easiest. But if you feel more comfortable with your calculator, let's see what we can do here. So if I were to type in, if it's a perfect square, then when I type this into my calculator, 18 over 98, I'm going to get a repeating decimal or a terminating decimal. So let's see what we got. 18 divided by, not 49, but 98 equals. Now I'm going to find the square root of that. 0.428571. 0.428571. Okay. Ooh, 428571. Ooh, 428571. And it just keeps on going like that. So we have a repeating decimal. So we have a perfect square. Awesome. So for question B, we have 5 over 16. So if we were to use this second one here, if in lowest terms we have a perfect square over a perfect square, 16 is definitely a perfect square. 5, though, is not a perfect square. So we're going to say this whole fraction is not a perfect square because 5 is not a perfect square. I'm just going to check on my calculator. We're not going to write this down or anything, but if I go 5 divided by 16 equals, and we find the square root of that. Now, if it seems to be a repeating pattern, then we know that it's a perfect square. But if it's not a repeating pattern, which is what we're anticipating, then it's not a perfect square. 5590169943749. Okay, there is no pattern to that. So it is not a perfect square because the answer is not terminating and it is not a repeating decimal. Question C, 4 over 3. we're saying, yeah, 4 is definitely a perfect square. 2 times 2 is 4. Is 3 a perfect square? Nope. So this whole fraction is not a perfect square because 3 is not a perfect square. The second or the third example here is related. So is each decimal a perfect square? If you're given a decimal, just use the calculator. If the square root terminates or is a repeated decimal, then the decimal is a perfect square. So for example, if we were to do the first one, 1.21, find the square root of that. It's 1.1. So with A, the square root of 1.21 is 1.1. Since it terminates, it is a perfect square. What about B? If I take the square root of 0.125, I have 3.53553390593. Okay, this one is 0.5. We'll do this. 5, 3. Oh no, sorry. 3, 5, 3, 5, 5. It was looking promising there. 3, 3. But then it just goes all crazy. 905 da 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 da. So, since it does not terminate and is not repeating, it is not a perfect square. So the summaries: perfect squares and square roots are opposite operations. So, for example, 6 squared equals 36. The square root of 36 equals 6. You know a number is a perfect square if it is rational. That is, the decimal does not exist, or the decimal terminates, or is a repeated decimal.